All right, everyone, welcome on back here to Finance with Frittles. I hope you're having a good time, and if you feel so inclined, go ahead and hit that subscribe button down there for me. The last couple of videos, we've gone over the time value of money, and then we transitioned into a finite annuity, and we kind of covered at a very surface level exactly how those work in the real world with insurance companies, annuity salesmen, and people like you and me to whom they're trying to sell. But now in this video, we're going to go over a little bit of an actual calculation or practical application to apply the finite annuity system in a real world situation. For example, if you want to go out and buy a car, you don't know exactly how much of a car you can buy, but at the end of the day, you know how much you can afford in a monthly payment. It's a good option to go ahead and see just exactly what kind of car you can afford. Another way to look at it is if you're approaching retirement, or you think you've got enough in the bank to be able to get close to that retirement period, you can do a little bit of a calculation. If you know exactly how much you need each year, and therefore exactly how much you need each month, you can back into a current situation wherein you find just exactly how much money you'll need in order to retire now. We'll take a deep dive on in the following practical application of finite annuities here on Finance with Frittles.
Okay, so for the first application here, we're going to presuppose that we've just gotten done completing our budget. And we recognize that we can afford a $600 payment every single month on a car. And we call our local bank. We say, hey, we'd like to purchase a car. We're interested in financing this vehicle, and we're wondering if you would loan me a vehicle. And the bank says, hey, yeah, we'll give you a loan. We'll give you a loan at 4.5% for 24 months or 4 years. And so the ultimate question is here, how much can you borrow? In other words, what's the most expensive car you'd be able to actually finance or get from that dealership? So as we begin our analysis here, it's best to kind of take a look at the variables we have and make sure we annotate those correctly. So we know the payment that we're going to be able to pay every month is equal to $600. Why? Because we did our budget and we recognize that's the most that we'll be able to pay on a vehicle. We also know that the car loan is going to come from our bank, and that's going to be at an interest rate of 4.5%. Now that 4.5% is going to be the APR or annual percentage rate. That's not going to be the same rate that we pay per month, so we'll need to include that in our calculations. But the N right here, the number of periods, we're going to need to know that too. That's going to be the same as 4 years or 48 months. And the reason that we use N in months form is because our payment over here, our payment is every month. And so we want to make sure that the actual payment, the period to which that payment applies, is the same number of periods or the same respective periods here on the N. So we're going to use months for our N down here, and we're going to use payment per month. Now the other thing we're going to use is this I. This is a 4.5% per year, but that's going to be the same as 4.5% divided by 12 on a monthly basis. So this will be our monthly percentage rate. Okay, so we know that the equation for a finite annuity states that the present value of all those payments in a finite annuity is equal to the payment that we pay or receive every month divided by the interest rate times 1 minus 1 over 1 plus r to the n. All right. So what's important here is we need to know that this payment and the interest rate and the n, all three need to have the same associated period. So we're going to use months or monthly periods here. So we need to make sure that we have this correct. So the first check is this $600? Is this how much we're paying every month? Yes, that is indeed what we're doing. So that's a check there. As far as the R goes, we're going to be using this 4.5% divided by 12. So we understand that down there. We'll make sure that we plug that both in the R here as well as the R there. And the last one is this value N right here. We need to make sure that it's in months. So we're going to use this value 48 to make sure that we calculate that correctly. So that's the same as 600 divided by 0.045. That's 4.5% in decimal form divided by 12. And then we're going to multiply that value by 1 minus 1 over 1 plus r, and that's again 0.045 or 4.5% in decimal form, divided by 12, and that value is going to be in parentheses raised to the power of n, which is 48 months. All right, so if we actually run this calculation, we find out that the present value of all these payments is equal to $26,311.77. In other words, the most expensive car we could purchase would be a car that costs $26,311 because that's the maximum price on a car that we could pay while still paying just $600 every single month at a 4.5% annual percentage rate over a period of 48 months. Okay, quickly now, just one last example. Let's say that we've decided that we want to retire this year, and we've calculated that we'll need about $7,000 a month from our investments in order to retire. So we looked at our budget, and in addition to any Social Security payments or other income that we might have, we know that we want to have $7,000 coming in every month to support us to do what we want to do in retirement. And you know that you want your investments to last for 35 years. So we're gonna retire here a little bit earlier than the standard retirement age, which is good for us. And we believe that we can earn about 4% annually with your investments. Nice conservative portfolio there. But we still believe that even when we're concerned chiefly with capital preservation, we can still eke out a good 4% annual return there. But the ultimate question is, how much do we need to retire right now? Well, we can use the finite annuity formula to find the present value of all these payments and find out just how much we need to actually have an income here at $7,000 every single month. So in order to calculate this figure, we start off with our variables, and we start off with the payment every month. Remember, that was equal to a value of $7,000. That was what we wanted to have come in every month. We also know that we can earn a rate of return or an interest rate at about 4% per year with our investments. Now that's on an annual basis, so we need to convert that guy into a monthly basis. So that is going to be 4% divided by 12, or about 0.33%. On a monthly basis. We need to have that figure be the value for R in our formula. So that's our interest rate. But if we're looking for one more variable, what would it be? Oh, that's right, the N, the number of periods that we need this. Well, that's equal to 35 years. Well, we need to have that in monthly form, so we're going to multiply by 12 and come out with a value in months of 420 months. So we've got our value for the payment up here, we've got our value for the interest rate, and we've got our value for the number of periods N. So we can use the finite annuity formula, which states that the present value of a finite annuity is equal to the payment that we receive every period divided by the R in that period, multiplied by 1 minus 1 over 1 plus R in that same period, raised to the N, or number of periods that we have. And what's important here is we need to make sure that our payment, our value R, both in the denominator here and the denominator here, as well as the value N, all three need to be in monthly format or in the same periods. If we have them on an annual rate, that's fine. They would all need to be annual. But we're looking at a monthly here, the $7,000 figure, that's a monthly figure. So we're going to make sure that each one of these variables is in monthly form. So we're going to start off with our payment. That's $7,000. We're going to divide that by R, which was 4% or 0.04 divided by 12. Make sure we have that in the denominator correctly. Then we're going to multiply that value by 1 minus 1 over 1 plus R. Remember, that's the same value, 0.04, 4% divided by 12. And we're going to take that guy in the denominator here, and we're going to raise it to the power of N, which is going to be 420 months, or 35 years. So that's our formula that we have. And once we run that calculation, we find out that the present value is equal to a figure of $1,580,000, 939, and if we're going to be really precise here, 32 cents. So this is the sum of money that we need in our investment account today, right here, in order to pay us out $7,000 every month for 35 years. And what's really interesting is we can look at this in an amortization schedule within Excel. So this is kind of interesting if we look at this. This guy right here, I simply input the information that we had. The interest rate on an annual basis was 4%, so that's 0.33% monthly. Our income there, that's $7,000 or $84,000 a year. And our value N was 35 years. That was the number of years that we needed these payments to continue. That's equal to 420 months. So this value starts out here. We said we needed $1,580,939. Let's go ahead and check that. Well, the way I've got this working is at the end of the first month here, I've got this account value at the end of the month, which grows from our initial investment of $1,580,939 to $1,586,209. So you can see that 0.33% growth over that first 30 days there. But then I have the second column in blue here that says the account value at the end of the month after we have our payment. So we take our payment out of the account. Our account drops from this value here to this value here at the end of the month when we pay ourselves. So it drops from $1,586,000 down to $1,579,000. The next month, in the subsequent 30 days at the end of month 2, it's grown again from $1,579,000 up to $1,584,000. That's the increase or growth that we have at 0.33% per month. The same thing as 4% on an annual basis. We then, at the end of month 2, subtract out another $7,000. So you can see it drops again from $1,584,000 down to $1,577,000 and change. And each one of these values here in the blue column is going to be exactly $7,000 less than its associated value on the left, because that's the way we've calculated it here, is we've grown it, and then right at the end of the month, we go ahead and take that payment out. So what's really cool is if we scroll all the way down here to the end of 420 months, or 35 years, we can see here that in the 419th month, we have about $6,976, and that's after we've taken out our $7,000 payment at the end of that month. So we only have 1 month left, but you can see at the 0.33%, it grows just enough to barely give us $7,000 there in the 420th month. At the end of that last 30 days of the last 420th month, that's the end of the 35 years, we have $7,000, and when we make our payment to ourselves, boom, the account is depleted, and from top to bottom, we have shown that through an amortization schedule, we can see that this figure of $1,580,939.32 is precisely on the dot to give us $7,000 every month, such that in the very last month, in the 420th month, we'll have just enough to deplete that account.